Okay, so this is my 4th period recording. So if you're in 6th period, make sure you click the other link. This is not the one you want to listen to. Alright, so we made it to example 4. And so here it says for each of the following functions, we're going to sketch the function, find the inverse, sketch the inverse, and verify that their inverses algebraically. And I'm going to go through it kind of quick because remember this is a recording, so you can pause it and you can back up and re-listen to it if you need to. Alright, so let's graph this function. So it says f of x equals 2 minus x squared. Well, it's a little different than we're used to seeing. We usually see the numbers that are separated at the end. So we can rewrite this as negative x squared plus 2 to help us graph it. So we know that our parent function then is x squared. So I'm going to go grab my parent table for x squared. And so I'm going to use the x's, a negative 2 to positive 2. And then I'm going to square them to get the y's. Now, for my function here, it's we have that negative, which remember means it's going to reflect across the x-axis, and we got that plus 2, which means it's going to be a vertical shift up 2. And so when I go to do my table for my function, there's nothing inside with the x, so that means nothing's going to affect those x values. So they're going to stay the same. So I'm going to go ahead and write them back down, negative 2 to positive 2, which means the negative and the plus 2 are outside of the x area, so therefore they're going to affect the y. So we're going to take our y's, we're going to multiply them by the negative 1, and then we're going to add 2 to that. So I notice my first and my last one are the same. So when I take 4 and I multiply by negative 1, I get negative 4, plus 2 is negative 2. Now my second and my second to last are the same, so when I take 1 times negative 1, I get negative 1 plus 2, which is 1. And then the middle one there, I have 0 times negative 1 is 0, plus 2 is 2. So I'm going to graph those points. I can see it does look like a quadratic. It has a parabola. Alright, so I graph it. The problem is, though, that this function is not one-to-one. When I draw a horizontal line, or use my horizontal line test, it fails it. So therefore, that means that the inverse won't be a function, and I want my inverse to be a function. So I need to restrict the domain. In order to do this, I need to cut off half of this graph. So notice where it's symmetric. In this case, it's symmetric about the y-axis there. So on this line right here. And so I can choose to get rid of the left side or the right side. The left side here is what we consider our negative side. The right side is our positive side. We usually like to keep the positive side because when we do our inverse, I'll remind you of it then, okay? So I'm going to go through here and I am going to take off the left side of my graph. Now, because I did that, I just took off those first 2 points that were in our table. So if I'm going to use my table to graph my inverse, I need to take those points off because I don't want to try to graph them for the inverse function. Alright, now I'm going to go ahead and graph my line y equals x so that when I do graph my inverse function, I can verify visually that they're inverses of each other. Now, I have a choice. I can go find my inverse function, and then I can graph that, or I can go ahead and graph using my original function and then just verify that my equation I get for the inverse looks like the looks like the answer, or looks like the graph that we get for our inverse here. All right, so I'm going to go ahead and graph using my function to help me. So for my inverse of f of x, remember, the inverses, the x and y's are just switched, right? Input and output switch. So that 0, 2 is going to become 2, 0. 1, 1 is 1, 1. And 2, negative 2 is negative 2, 2. And so I'm going to go graph those points. And then I'm going to verify visually looking at these, do they appear to be inverses? Well, remember, inverses are reflections across that line y equals x. Do they look like reflections across the line that I drew in? They should. Yes, they do. All right, so now we're ready to find our inverse function then. All right, well, we already talked about the steps when we did example 1, the steps that we needed in order to find our inverse. So let's go through and do it. Oh, one other thing I did forget to write up here, because we did cut off half of our graph, we need to write what our restricted domain is. So if you look at my graph in blue, we did have our x, where we cut it off, they were all now greater than or equal to 0. And so we need to write that there so that later, if we go back and we compare it, we understand why they were able to be inverses that are functions. All right, now back to finding the inverse. So remember, we had some steps that we had written out and looked at. And the first thing is that we're going to switch our x and y. So we have y is equal to, I'm sorry, I said that wrong. We're going to switch f of x to be y. So we're going to change this f of x equals to become our y equals. All right, then the next thing we do is we switch x and y. So everywhere that's an x becomes a y, and everywhere that's a y becomes an x. And then we just need to solve for y. So I'm going to subtract the 2. And so we get x minus 2 equals negative y squared. Divide by the negative 1, everything. And so we get negative x plus 2 equals y squared. And I need to get rid of the square, so take the square root. And so we get y equals, because the square and the square root cancel, we get plus or minus the square root of negative x plus 2. Now if you wanted to write that as 2 minus x, you definitely can, if you don't like your negative out in front. Now, and this is why I use the positive one, because some of y'all will forget to put your plus or minus. If you forget to put the plus or minus, it's automatically going to be positive, because I'm pretty sure you're not just going to put a negative there. So that's why I use the right side of the original one, because it's the positive side. So if you forget, you're covered right here. All right, so we're actually just going to use the positive square root of negative x plus 2. Because we had said, remember originally here, that x had to be greater than or equal to 0, which means for our inverse, our y needs to be greater than or equal to 0. So therefore, our y right here has to be positive. All right, and then the final step on finding the inverse is you just need to put it back into function notation. So the inverse of f of x is equal to the square root of negative x plus 2. And so there is our inverse function. Now we get to verify that they are inverses algebraically. Okay, we looked at the graph. We said graphically, yes, they look like inverses. Oh, and before we do that, though, let's look at our transformations. Now remember, because we do have that negative inside, remember that's the tricky one. So it says we're going to have the square root, and we have to take it out. That's a negative, and then x minus 2. So look at our graph. The negative there tells us it should reflect across the y-axis. Well, my pink one is reflected across the y-axis compared to the parent function of a square root. And then inside the parentheses there, it says x minus 2. That means it went to the right 2, and it did. So our graph of our inverse fits our equation. All right, now let's verify them algebraically. So this is where we take one equation and we plug it into the other. So I'm going to take the original and I'm going to plug into it that inverse function. And guys, it doesn't matter which one you do first, as long as you take the original function and plug it into the one we found, and take the one we found and plug it into the original function. All right, so since I wrote it out this way, remember the outside one is my skeleton. So f, the original one's going to be my skeleton. And it's 2 minus x squared. And we're going to plug that inverse function right here into it. So our inverse was the square root of negative x plus 2. Then we just need to simplify that. So when I look here, now I need to work inside parentheses. There's really nothing in parentheses. And then exponents. Well, this square and square root right there will cancel. So I have 2 minus. Now I'm subtracting everything behind it, so put it in parentheses. So I have a negative x plus 2. Distribute your minus. So negative x is positive x. And then we have a minus 2. Your 2's are like terms, combine them, and we just get x. And that's what we want, because if we don't get x, we've messed up somewhere. All right, but then remember, you have to do the reversal one. You have to take the inverse of f of the original. So because the inverse of f is on the outside, that means our function that we found, our inverse, is our skeleton. So it's the square root of negative x plus 2. And so then we're going to plug in our original function here into it. Our original function was a negative x squared. I'm sorry, let me write it the way they did. So 2 minus x squared. All right, and then we just got to simplify that. So everything's under the radical. So I can't work inside my parentheses. There's no exponent to deal with there besides the x squared, and I can't do it. Multiply. So I'm going to take this negative and distribute it. So I still have my square root. So I have a negative 2 plus x squared, and then I have a plus 2. Well, negative 2 plus 2 will cancel. So I'm going to come over here. So we have the square root of x squared. A square and a square root will cancel, and so we just get x. And so we just showed algebraically that they are inverses. All right, so remember, if I went too fast, back it up, okay? Watch it again. So we're going to do 4b, and then I want to add in one additional example. We're going to add on a separate sheet of paper, okay? All right, so we're going to do the same thing here that we just did. So first, let's go ahead and let's find our graph. Let's graph the function. So I can see that it's a cube root, so that means that my parent function is the cube root of x. And so we use negative 8, negative 1, 0, 1, and 8. So that could get the cube roots of negative 2, negative 1, 0, 1, and 2. Now for the function it gave me there, it says that plus 2, remember, it's going to be a horizontal shift to the left 2, and then minus 1 is a vertical shift down 1. So when I go to do my, whoops, they called it g of x this time. When I go to find g of x, my transformed graph, what are we going to do to our x's? Well, it says x plus 2. Remember, we do the opposite, so subtract 2. And then it says we have a minus 1 at the end, so we're going to subtract 1 from the y's. So we're going to take all of our x's and subtract 2. Take all your y's and subtract 1. And then graph those points. Check. Does it pass the horizontal line test? It does. So therefore, we do not need to restrict our domain. So if we want to go ahead and graph our inverse function, Remember, we can just switch our x and y's. So all of my x's become my y's. All of my y's become my x's. And so we can graph them. What I didn't do is I didn't draw in my line y equals x. I'm going to do that real quick here. I'm just going to draw a solid line in to make it quick. Just so that we can check to make sure, are they reflections across that line y equals x? And it does appear that they are. So now let's go find our inverse function. So remember, our first step is change g of x to y. So y is equal to the cube root of x plus 2 minus 1. And then switch your x and y. So x equals the cube root of y plus 2 minus 1. And then solve for y. Right now that y is under the cube root, so let's move the 1 over. So x plus 1 equals the cube root of y plus 2. Then to get rid of the cube root, we have to cube it. So we're going to cube the whole other side. So we got x plus 1 cubed equals the cube root and a cube cancel, so you get y plus 2. And we're still trying to solve for y, so subtract the 2. So we get x plus 1 cubed minus 2 equals y. And then remember, take it back to function notation. So instead of y, we're going to put the inverse of g of x is equal to the x plus 1 cubed minus 2. Now let's take this and let's look at the graph that we graphed. Let's see if it matches up. So let's see, this says it's a cubic, which mine has a cubic shape if you look at my kind of pink looking one. It says it's got the x plus 1, so it meant it went to the left one, and it has a minus 2, so it went down 2. So remember that center point was at 0, 0, and it has gone to the left one and down 2. So it looks pretty good. And then we just got to find those compositions. So we're going to take g of the inverse of g of x. So g's on the outside, so the original one's my skeleton. So it's the cube root of x plus 2, and then a minus 1 on the outside. The x, what we're plugging in then, is going to be my inverse function. So I look down there, and it's x plus 1 cubed minus 2. So then we just need to simplify that. So work underneath that radical. I can't work anything in that parentheses, but I don't really need the parentheses, so if you wanted to, we could just omit them. So we'd have our x plus 1 cubed minus 2 plus 2 with the minus 1 at the end. Our 2's will cancel. So we have the cube root of x plus 1 cubed with the minus 1 at the end. The cube root and the cube cancel. So now we have the x plus 1 and the minus 1. Well, no. Excuse me, I don't really need parentheses, so the 1's are cancel. And so we're just left with x, which is what we wanted. So then we've got to do it the other way. So we're going to find the inverse g of x. So remember, the inverse is on the outside, so it's our skeleton. So it's x plus 1 cubed minus 2. And our g of x is what's on the inside, so we're going to go and plug that in. So it's the cube root of x plus 2, and then minus 1. All right, I don't really have to have that inner parentheses there. So I'm going to rewrite this, kind of spread it out a little bit and drop that. So I have the cube root of x plus 2 minus 1 plus 1 cubed with the minus 2 at the end. Okay, our 1's will cancel. So we have the cube root of x plus 2. I don't really have to have the parentheses now because it's everything that's inside the parentheses is underneath that cube root. And then it's cubed minus 2. The cube root and the cube cancel. So we have x plus 2, and then I still have my minus 2. The 2's cancel, and we get x, which is what we wanted. All right, and one more that I want us to look at. All right, so let me find where my paper is. I have a way I can pull up a sheet of paper here. Well, just a second. It's been a while since I did it. There it is. Okay, so I want us to find the inverse of this problem. One second, gotta find what I did with it. Here it is. So we want to find the inverse of f of x equals 2x plus 3 over x plus 2. Because we hadn't looked at one on what if they give us a fraction. Well, the steps are exactly the same as if it wasn't a fraction, except for when we go to solve for y, I'm going to give you some extra little steps to help you get through it. But it works every time on every one like this, okay? All right, so the same steps we had before. First thing we're going to do is we're going to switch the f of x to be a y. So we have y equals 2x plus 3 over x plus 2. Then we're going to switch x and y. So we get x equals, now it's 2y plus 3 over y plus 2. So this is where we run into the issue because we got two different y's. And we need to find a way to kind of combine them before we can solve for y. So the first thing we're going to do is we don't like fractions. So I'm going to write down these steps as I go now, okay? So to solve for y, first thing we're going to do is we're going to multiply by the denominator. All right, so I'm going to multiply both sides by the y plus 2. So we get x times y plus 2 equals, and this side's going to cancel, so we get 2y plus 3. So then we're going to distribute the x. So we get xy plus 2x equals the 2y plus 3. Now we're going to get put y terms on one side of the equal sign. I'm just going to say of equation. And non-y terms on the other side. So if it's got a y in it, it's going to go, I'm going to put mine on the left. If it doesn't have a y in it, I'm going to put it on the right. All right, so my first term here, this has a y in it, so I'm going to leave it. The 2x does not, so I'm going to move it to the other side. Well, it's not even a like term there, so let me just put it over here. All right, check the other side. The 2y has a y in it, so it needs to go to the left. I'm just going to write it down here, even though they're not like terms. I don't have any other room. And then the 3 doesn't have a y, so it's going to stay on the right. All right, so what I end up getting now is I have xy minus 2y on the left equals 3 minus 2x on the right. Now, we still can't combine those two y's, but they have a y in common. So we're going to common factor out a y. So because both of these terms have a y in common, I'm going to pull it out in front. So I divide that out. That's going to leave me with x minus 2 equals the other side. And then the last step is we're going to divide by whatever's in the parenthesis. So I need to get y by itself, so I'm going to divide by the x minus 2. And so we get y equals 3 minus 2x over x minus 2. Alright, so we solved for y, so now I'm back to the original directions, which then says just put it back in function notation. So the inverse of f of x would equal 3 minus 2x over the x minus 2.